Qwen Image Plus, a powerful image editing model with some impressive updates. In just a few days, we've added support for the double-stick acceleration model and the corresponding 8-step lightning LoRA. So the generation speed at this point is already very fast. There is also LoRA trained by the master to solve the pixel shift issue in the 2509 model. It's Qwen Image Editor and image editing model, doing global editing, but sometimes we just need to change part of it. After loading, it can save a lot of effort. My approach to handling pixel shift is to turn the 2509 model into a local repaint stream, then perform an operation similar to universal migration. This way, except for the areas we're currently editing, almost everything else remains unchanged. Then let's look at the workflow. I'm using RunningHub, the largest online compute platform globally. The inspiration for this workflow is almost entirely based on the previous process of migrating everything. Let's start with its core component. We use the double-stick node for loading, and our quantized model still remains an 8-step configuration. The lighting and 8-step process after this model indicate that it has already integrated acceleration capabilities, so there's no need to load an independent acceleration model separately. This is used to solve pixel shift issues with LoRA models. It's not necessary during the transfer process, but if you do use it, only apply very small weights. So if we want to repaint a local area, we actually need to find an image, input it, and then paint a mask over it. I do it the same way as before. After sending it out, we can cut it again. Then why do we need to edit it again? Sometimes the area we want to focus on is very small, so we can crop a square based on the mask edge. So the part we let the model edit was very limited. Putting it back in the original image will be clearer. Before, we used to do it at 15,000 per piece, and that's always been the way we did it. If you're dealing with images, you need to encode them, and for latents, you have to set up a noise mask completely typical of the 9-layered approach. During this process, I actually wanted to hand him this rice cooker. Holding the rice cooker with your hands is definitely a failure, but moving this rice cooker in is completely fine. Continue with Hushi's timeline, and you'll see there's no visible seam at all. Navigate to RunningHub, click on AI, or click the link in the introduction to register, and you'll receive 1,200 points. Logging in daily will also give you 100 points, the corresponding AI workflow, and one-click start AI applications. They have been deployed online in sync and can be run and tested online. Let's look at a few examples next. So I think the transfer learning process of the 2509 model is more suitable for situations where both parties don't need to interact very intensely. For example, having this person ride a motorcycle is not a very difficult interaction. At this point, it's very easy and effortless to complete the task. Let's take a closer look at this masking area. The way we apply the mask isn't exactly the same as the local repaint feature in our previous image model. Previous local repaints only affected this area, the painting here. This is to narrow down the area where our global effect applies, because after all, it should still be a global edit. After coming out, there was almost no visible seam. The third one requires effort. We've already done the migration for an electric rice cooker before. The rice cooker migration performs better in the GPU stream of the 2509 model compared to contest. It adjusted its direction flexibly and blended into the scene. The fourth one exerted force. We held axes in our hands. In terms of results, including the reference images, similarity, and task completion rate, they were already very low. So this migration process is relatively suitable for scenarios with simple interactions. If we want to transfer within the basic workflow, there may be several issues. One is the loss of clarity since we didn't crop and reapply the image, and even if we use an anti-pixel shift LoRA model, it might still struggle at the seams. With advantage, we tested this before. Bringing the two elements closer makes it easier and more natural. But now we're back to the old problem, pixel shift calibration and image clarity. The support for this places between 0.5 and 1 in terms of LoRA weight adjustment, so it doesn't actually reject anyone. Instead, it applies different processes based on specific situations. Let's look at another result from the single image. This woman wants to eat an ice cream, which is actually fine. We need this quantized model combined with a LoRA model that prevents pixel shift with balance weights set to 0.5. At this point, I think it's already very comprehensive for editing single images. Previously, our consist model had a process that took an image and blended it onto a background image, then merged them together seamlessly. I tested it and found that the $1 million image editor still works. It may seem there are still some issues, but maybe it's just a matter of probability. We just need to switch the model. Just increasing steps can solve problems like this. So most of the time, this channel shares open source models and projects, but closed source models are where RunningHub really shines. He brought down the prices of many popular models such as V2, Kaling, and Wangxiang. Some specifications were even lower than the official published prices. The more you use it, the more you'll realize that saving up bit by bit really saves money in the long run.